Hey guys, welcome back to my channel Advait OMG. In today's video, we'll be seeing how to make a calculator program in Python. So, if you don't know what Python is, it's basically a text-based coding language like code.org, but instead of blocks, you have to type everything in manually. Now, spoiler alert, this video is very complicated for a person who does not know Python at all. But even if you are a little familiar with Python and the basic algorithms, you can easily get through this. So, what are we waiting for? Let's dive right into the video. So, for this, I have created my own local library for all the functions such as addition, subtraction, multiplication, division, square, etc. First, let's take a look at the local library. The local library is present in satellite chitty directory, and inside that there is one more called calculator.py. So, first we have the import math. Math is a global library which can be used by anyone who is using Tony. This library has different math functions such as square root, cube root, because it's not easy to find them without the function. Then we create the actual library, class calculator. So the library's name is calculator. And then we hit a kind of unique code, @static method. What is this? Well, to understand what static method is, we have to learn what is object and what is class. Now, a class is very simple. It's just this thing. It's the library. So you can think of it as a blueprint. While the object in code is the variable which uses the library, or you can say a house. The blueprint on its own cannot do anything. The object is only the useful thing. Like this, the library on its own cannot just do anything. The object, or that is when it is called, only then will it do something useful. So, @static method basically tells us that. It tells the computer that this next code does not need the class nor the library. It can run on its own. So, here we have the function creating a function called add and the variables a and b, or input 1 and input 2. And then we return a plus b. What this basically does is it adds a plus b first. So, for example, if there is 1 and 2, then it will become 3. And then it will return the value 3 to whatever line of code in the actual code loop called it. So, for example, if I put in sum equals calculator dot add, and the values are 1 and 2. So, first it will add 1 and 2, become 3, and then it will return 3, and so it will assign the value 3 to the sum variable. That's a little complicated, but you can get it. And after this, it's basically just a repetition. @static method, define the function sub for subtraction, multiplication, division, and here we get an interesting, because if b is equal to 0, that is, we cannot divide numbers by 0. It's just undefined. So we are checking if the second value is 0. And if so, we return none as the value, and that is like this function cannot be carried out. And then if not, we just return a divided by b. And then the same thing for square, a multiplied by a. For cube, a multiplied by a multiplied by a. Now we come to the square root. So we define the function of square root, and if a is less than 0, That is, if a is a negative number, then we return none, because square roots of negative numbers cannot be expressed using only real numbers. That is, numbers that are positive, negative, rational or irrational. So numbers like I and E are not considered as real numbers, they are unreal numbers. And since the computer can't print those, we just return none and say the function cannot be carried out. And otherwise, we just use the math library square root function to find the square root of a. So it's a little complicated there, but basically it's easy. If a is a negative integer, return none, else carry out the function. Next up is cube root, and here instead of using the math library for the cube root function, we use a to the power of 1 upon 3. Now why do we do this? It's because the cube root function is in a later version of the math library, but Tony uses only old versions. So if we try to use math.cuberoot, then it will give us an error saying the function does not exist. So that's why we have to use this formula, this workaround formula, to find out the cube root. And the last function in the library is the power function, that is 2 raised to 5 or something like that. So here we just use the exponential sign or 2 multiplications to find the exponential. Alright, that's it for the local library. Now let's go on to the code. So here the first line is from satellitechitty.calculator, import the calculator. So we first need to import the local library which we have used, which we have created, then only we'll be able to use it. And we cannot just use import calculator because it's a local library. We have to tell the computer where it is. And in this case it's satellitechitty.calculator, what I told you about this. And then we create a variable called input1, or in the library it's a, but the names can change. Okay, so input1 is equal to float input, enter the first value. So this input function will basically ask the user, hey, what's the first value? Okay, and after that it converts the value into a float. Of course, the user technically can put a string, that is some text, but since we have used this float function, it will immediately give us an error because a string cannot be converted to a float. By the way, floats are just decimal numbers, if you didn't know. So next up we enter a while true. This is basically a forever loop that will go on and on and on unless we use a break function, that is to get out of the loop. But in this code we have not used a break function, so we don't need to worry about that. This will just go on forever. So then we create a second variable called operation after asking the user what's the first input, and then input operation, like what is the operation. And here there is a list of whatever operations we want, and we have to put it exactly like this, otherwise the computer will not understand. So if we want to put in multiplication, we have to put in MUL. Okay, and then we put in a dot lower. Now what this dot lower function does, it basically converts all the strings into lowercase letters. So even if you put like capital A, even if you put add in all uppercase letters, dot lower will convert it into lowercase letters so that the remaining functions later on can work. And if this is just in 2 lines, by the way, because if you put it in 1 line it will become very long, and yeah, it will just become very messy, you can't understand it. So we have put it in 2 lines. Now the last part is this new thing. So basically in a real calculator app there's the AC button to clear everything. So this new wala is kind of like that. Now we check if the operation is equal to new. If it is, then we need to put in input 1, ask again the user what is input 1, and then a continue. Now what this continue does is it stops the loop right here and then goes back to the beginning and repeats. So that's basically what continue does. because like if we are putting in a new thing, we have to ask the user a first thing, which we have asked here, and then again ask the operation which is in the first. So we put in the continue to repeat the loop. And then we start for the unary operations, that is the operations that only require one value, or like the square, cube, square root and cube root. Now we check in if the operation value is in this list. Now because we have put in this straight bracket, this is now a list. It doesn't have a name, but we don't need it. We don't need a name. So basically, if the user wants a square, cube, square root or cube root, that is if they typed in SQU, CUB, etc., we are checking here if whatever value they inputted is inside this list. Then we set an answer variable to get attribute calculator operation input 1. Now this is kind of a mouthful to see at once, but basically get attribute is basically like get the value which they have put in. Okay, so that's easy. If I put in square root, it will get square root. And then calculator is our local library. Operation is whatever operation they inputted or the get attribute. And then input 1 is the value which they need. Okay, so this will basically run like if we put in cube, it will go to the local library, run the cube function and return that value and all that. So this is basically a shortcut to putting a instead of if the operation is square, if operation is cube, like that. We can just use a list because all of these have something in common, and that is they only require one input. So the next thing is if the answer is none. Now remember how here we put in return none for some of the functions because the function was not possible to be carried out. Well, that's here. So if the answer is none, then we print in error. This is an invalid operation for the given value, or this operation cannot be carried out for the given value, and then we continue. So we start again from the beginning of the loop, and then outside of the if condition, print the answer in a string and the answer variable. So it will tell us the result. Then change the input 1 variable to the answer and then continue. So it will again go here, and since input 1 is the answer already, it will again ask the operation. Then when we put in the second value, it will continue. Now binary operations such as addition, subtraction, multiplication and division, these are relatively simple. We put in next value or input 2, ask the user what is the second value, or new if they want to clear it. And then if the next value dot lower, remember it is lowercase, this just lowercases all the characters. Next value dot lower is equal to new. So again we are checking if they have put in new, if they want to clear everything. If they do want to, then we know, we have already seen this up here. Now the input 2 is equal to the float value of the next value variable. Okay, and then the answer is get attribute calculator operation input 1 and input 2 this time. So we have seen this before. Basically we don't use that if operation is in this list, because if it was in the list, this code will run, not this. So we don't need to worry about it. If it's not in the list, then it skips this all and directly comes to here. So technically the options are by default. It should already know by process of elimination. So then if the answer is none, again accounting for this, return none. Then we print error, invalid operation, and start again from the beginning of the loop. And then finally we print the answer, and input 1 is equal to answer. And since this is a while true loop, it will again go back to the beginning. So it's essentially, we can just put in a continue here and it's the same thing. Wow, that was a lot. But now let's try and run the code. So now it's asking us to enter the first value. So I'll enter in 1. Now it's asking us the operation, so addition. Now here we have the next value, so I'll put in 7. And now the answer is 8. Now it's asking for the next operation. Now let's see, I'll put in cube root, because 8 is actually a cube. It's the cube of 2. So I'm asking for the cube root. Now it should come 2, and yes, answer is 2. Now let's try multiplication with a decimal. So 3.2. So I'm basically asking 2 into 3.2, and that is 6.4. Now let's put in division, but now we'll check if this if the lower function actually works. So I'll put in div in all capital, and the computer is unfazed. So 6.4 divided by 6 is 1.06666667. Now let's try the power and enter the next value. So we are going to put in this raised to, let's see, I'll just put in 2, and then we got this value. And now let's try and clear it by putting in new. Alright, enter the first values back, 4. Now let's see. Yeah, it basically forgot everything that was behind, that was before. So our calculator program works. So guys, that's it for this video. That calculator program was a lot to take in, but eventually if you give it time, it will all sink in and you'll understand it. If you like this video, please don't forget to smash that like button, subscribe to my channel, and turn on the notification bell to get notified whenever I upload a video. Bye guys!